rather. What characteristics? So what? So you can do whatever you want to do. You don't have to do anything. All right. I would recommend it, but you don't have to.
I think I just get more out of the study guide. I always lose them sometimes.
Fair enough. Wave characteristics. Okay. So, what are certain wave characteristics? All right, so here's a wave. Here's a wave. Okay. What we have at the very top of a wave, you got the crest. At the very bottom, you got the trough. Okay? Hopefully that's kind of familiar. From our midline to our crest, or from the midline to the trough, same thing, the amplitude. Okay? And then from a trough to a trough, a crest to a crest, those are our wavelengths. Okay? That's our wavelength. Okay, that's what we got. Okay? Crest, trough, amplitude, wavelength. All right? Got that. All right. Just the definitions of them. Okay. Do we feel good on that? Just some terms of where things are located on wave. Okay. All right. Now, what is a period? Okay. We know frequency. What is a period? Okay. Oh, got some dots. Period. It is the time to complete a cycle or wave oscillation to occur. Okay. So it's the time to complete a cycle. Okay. And it's measured in seconds. Okay. So the period is the time to complete a cycle measured in seconds. Okay? Good to go? All right, so we know period, frequency, going over these terms. Like I said, today we're getting a lot of background information. Frequency is the number of wave cycles that pass in a given time. Wait a minute. What's the difference between frequency and period? Okay. I'm going to go back here for a second. The period it's the time it takes to complete a cycle. So, from here to there, what is that time? Right? How much time did it take from there to there? Okay. The difference is frequency. Let's say we have a given time. Okay. We have a given time. I need to erase it. Okay. So let's say this is our time we're given. We're given this much time. The question is, how many waves occurred in that time period? That's a lot of waves. That's pretty crazy, huh? Okay, so that's frequency. That's the difference. Okay, and this is measured in Hz. That's kind of hard. Hz stands for hertz. Okay? Hz stands for hertz. Okay, good? All right, now this is our equation. Frequency is equal to 1 over the period. Okay, so they're kind of like opposites? Yeah, actually, that's pretty good. Yeah. Okay. So frequency is 1 over the period. 1 over the period. I would write that down. Okay. Okay. And we'll go over examples that have that. Okay. Wave speed. What is the speed of a wave? Okay. It compares the length of a wave to how fast it occurs. Kind of makes sense, right? We know what speed is. We've learned speed, right? Now the speed of a wave is just the length of the wave with its frequency. Right? The length of the wave with its frequency. And here's this equation. Okay? So wave speed is equal to the frequency times the wavelength. Frequency times the wavelength. All right. We're hitting a lot of different things here. Okay. Okay, so let's try out an example. Try this one out. Okay, so if we try this out, we know the frequency of 264 times the wavelength. We know the wavelength is 1.30. So if you multiply those two together, your answer should have been about 343.2. And the unit is meters per second. How do we feel on that? Pretty straightforward, not too bad. Okay. Nailed it. Okay. Now, this wave speed, it's hard to picture, but when you talk, you can hear me pretty clearly, right? But if I'm on the other side of this door and I talk just like I'm talking, could you still hear me? Really? Maybe a little bit. A little bit, but not as good. Why? Say what? There's something blocking. This is a solid door right here, right? So when there's complete well, that's what I mean by different mediums. So one medium is through a gas, one medium can be through a solid. Has anybody ever tried to speak to each other underwater? It's kind of hard, but can you do it? Yeah, you can do it a little bit, right? All right. So most waves travel slowest in a gas, okay, and faster through solids. Okay, why? Why in the world does that happen? It travels slower through gas, but faster through solids. Anybody got a guess? All right. So in a gas, the molecules are kind of spread out and they fly everywhere. Right? But if you look at a solid, like a solid ice cube or something, looks something like that, right? They're all really close to each other, right? So when I talk in a gas, I'm going to hit this particle, and eventually it's going to have to hit something else. And eventually it's going to hit something else, and that's going to bounce off that. But if you talk in a solid, if you talk and hit the first molecule, it's like a domino effect, and then eventually it's going to hit the end, right? Pretty crazy, right? Crazy concept to think about. Now, one thing we're going to be talking about a little bit today, and honestly a lot of next week, is electromagnetic waves. Okay? Electromagnetic waves. There's 7 types of electromagnetic waves, and they all travel at the same speed, and that speed is the speed of light. Okay? Big number, all right? You will eventually have to know this number. Okay? That is the speed of light. 3 times 10 to the 8th. That's a big number. 3 times 10 to the 8th meters per second. That's 300 million meters every 1 second. That's pretty crazy. That's so fast. 300 million meters per 1 second. Okay? So electromagnetic waves, they travel at a speed of that. Okay? We're cruising through this. We're already over halfway done. Okay? Feel pretty good? All right. This is the Doppler effect. Now, have you guys ever sat in a car and a fire truck was coming down the road or a cop car was coming down the road? So your parents pull off and you hear the siren coming, but then it passes you. What'd you notice? Has that happened to anybody? Connor, what did you notice? It goes away quick, right? So you hear it a long way away, but as it passes you, it gets so quiet. That's the Doppler effect. Okay? That's the Doppler effect. An observed change in the frequency of a wave when a source or observer is moving. Okay? So when one is moving, that creates a Doppler effect. Okay? Like my little example. All right. So as the source is creating, it moves closer, the frequency of the wave increases, creating a higher pitch. And as it moves away, it decreases. That's pretty crazy. Okay. That's the Doppler effect. Pretty cool. Pretty cool. Okay. We just went over all different types of characteristics. All the characteristics we're going to need to know about waves. Okay? How do we feel about that? Pretty good. Is it kind of a review? Some new stuff, some old stuff? Okay, let's keep going. Now we're going to look at four different types of waves. Okay, types of waves. Okay, what are different types of waves? Okay, type number one, mechanical. Okay, type number one is mechanical. My lights are kind of covering that a little bit. Mechanical waves, they require a medium. What is the medium again? So, so like a solid, liquid, or gas? Yeah. So when I'm talking, is that a mechanical wave? Yeah, absolutely. It's traveling through air. It's traveling through gas. That's a mechanical wave. Okay? Requires a medium. That's mechanical. All right? Earthquakes. Travels through ground. The ground is a solid, right? So earthquakes are mechanical. Let's see. Waves in a pond. Those waves are traveling through a liquid. Perfect. And sound waves. So just some examples of mechanical waves. Okay? So we have solid, liquids, and gases. Earthquakes are actually really fascinating. Has anybody ever seen San Andreas Fault? Yeah. Great movie, very scientifically accurate. Very good. Okay? Next one. Electromagnetic. How fast do they travel? Does anybody remember? We just said this.
3 times 10 to the 8.
3 times 10 to the 8. They travel at the speed of light. Okay? So waves that consist of oscillating electric and magnetic fields. So they travel through space. Wait a minute. Does space have a medium? It's a vacuum? No, you're exactly right. It's a vacuum. So it doesn't have a medium. So that's why electromagnetic waves can travel through space. There's no medium. It's a vacuum. Awesome. Okay. So they consist of oscillating electric and magnetic fields. So, for example, light from the sun. I like light from the sun. Right? It gives us color. How cool is that? And we'll get a little more in detail on that here in a minute. So that's 2 of the 4. Electromagnetic. Okay? Third one. Transverse. Okay? The motion of particles in a perpendicular to motion. The motion of particles in the medium is perpendicular to the motion of the wave as a whole. Okay? I had a slinky. I don't know where it went. I'm really bummed by it, honestly. Yeah. So a slinky, it just kind of goes up and down if you push it up and down, okay? And the last one is called longitudinal waves. Okay? And there's the slinky. So it travels parallel. Travels parallel to the direction of the wave motion. So just a few types of waves you might see. actually pretty mesmerizing. I could watch that for a while. Then it'd probably put me to sleep, honestly. Okay, longitudinal. Okay, that's all the background information. Okay. Let you guys get that down real quick. Everybody good? All right, so what I did